welcome to Async Task, thread pools, and executors. Oh my! There are so many things about threading and thread management within not just Java, but things that are Android specific. What I'm going to cover here is what I consider the essentials. Or if anything else is derivative of something else, it got kicked out. It does not exist here, I'm sorry, but let's get on with the presentation. So this is me. If you want to know some stuff about me, information, things like that, again, I can show it at the end. But if you need to get in contact with me, if you have any more questions about what we're going to go over in this conversation, please feel free to contact me. So why do I need to know multi-threaded programming? So I consider this a core skill of the modern developer, right? Even when we're talking about the phones in our pockets, for the most part, what are they? Quad core, lots of RAM, faster than your computer in 2005. So we basically need the ability to run multiple tasks concurrently. And what I mean is that you can move both of your arms independently, and you can move both of your legs independently, and be able to accomplish different tasks with them. So to demonstrate this concept of what you are asking your phone to do on a continuous basis, everybody needs to try and pat their head and rub their stomach. Delicious food that we just ate. It's really hard, isn't it, right? So when we think about the concepts of multi-threaded programming, we have to think about the fact that we've essentially asked our phones to pat their head and rub their stomach at the same time. But fortunately for us, they aren't people, they're computers. We can make them do our bidding. Well, how do I make them do our bidding? Let's kind of go as what is a thread? A string does not represent a bunch of threads. And by that I mean the string construct, right? So I know sometimes we have these variable names and things like that that don't really make sense. This is one of them that doesn't really make sense. So thread is an independent execution worker. It is the worker bee. You are the queen bee. You get to tell the worker bee what to do. So all of Android works on the basis of threads. So when we're talking about something where you built like a Hello World app, a Hello World app primarily runs in what we consider a single thread, your main thread, which you'll also see some people call it their UI thread, although main thread is probably the best construct. So why do we need to know how to use threads? If you do anything with logins, if you want to load more information, if you want to cache information, if you want to use web and RESTful APIs, if you want to have stuff that basically goes on in the background without the user doing any immediate interaction with it, that also doesn't cause your app to go and stall, you need to know how to do threading. So Android has what I consider 4 basic types of threads. Now, you'll see other documentation talk about even more things, but we're going to focus on thread, handler, async task, and a thing called handler thread. Now, handler thread, you may have heard it just called the handler looper combo. They didn't want to call it looper thread, they called it handler thread. So just a thing to know for that. But things we're not going to be going through. Futures, intent service, jobs, and alarms. And the reason is that they are all actually, at their heart, derivatives of one of these 4 categories. So as long as you know how one of these 4 categories works, then you can understand what's actually going on in the background for things like futures, intent service, jobs, and alarms. Now, what you also see here is, wow, there's a lot of things that are Android specific. If we look at everything that's even mentioned on that page, only one of those things is actually a Java standard. And it's the most simple one. So let's talk about a basic thread example. We have something where we want to compute what I'm calling a root random, like a seeded random value. So if you have some like encryption or something like that, this would be kind of a direct analog to that. So if I want to make this run in the background, I need to declare all this stuff on the right-hand side and pass in my actual like long integer so that it would then compute that seeded random value in the background that I would perhaps use somewhere else. Now, why is this useful? Why would I want to have encryption or root random values computed in the background? It's because sometimes they're very, very big. And sometimes we don't think about the fact that an operation that we're asking or that we actually need for our application, it takes a lot of compute cycles. It can take a lot of values. So this is the basics. If you know Java, this is the basic example of how to actually generate a thread. Okay, I want a really simple thing here. Every so often, I need to send a signal to somewhere else that this process is still alive, or that my app is still running, or that I have a piece of information that's just kind of a timed element, otherwise known as like maybe a timer task. But here we're actually using it with a runnable and a handler. So handler actually is its own special type of thread in the background. And if I want to have things that are executed in services or in other parts of the application, I can do it really, really simply just by this code there. And what am I doing here? At the first part of it, I'm actually just declaring a new handler. Then I assign some random number, right? So in this case, it's going to be 5 seconds. And then I just have a runnable that I then execute in the handler. And at the end of when I've actually sent my life sign, I just post delay it. So that means that I can just have it continually run and self-propagate, but it also means that I'm allowing other things to run without interfering with it. And I'm also not holding the objects in that thread for any longer than I need to. It actually will generate as necessary, so that's really, really useful. Now, why would I want to know about handler? We can do a lot of things that allows us to have communication with like UI and main threads, and it's really good with stuff like messaging tasks. So, all right, I think we have a basic concept of what handler actually is kind of doing there, right? And we have the delay, and now we know how to do that. So this is probably the most common thing that you see mentioned about Android, right? You see Async Task. Now, Async Task can only be called from an activity or your main thread. It kind of sucks, right? Because sometimes you have things like services or other external classes that you want to have actually be able to run separated tasks. But there's some specific reasons why they made this, I call it a helper thread. This is kind of like the thread for beginners, helps you actually do and accomplish things without having to know a lot about what's actually happening in the background. So let's assume that I've made a new activity, and what I want it to do is actually load an image into an image view. But I still want the user to be able to like scroll up and down while I'm loading that task. So what would be a good thing for me to use is Async Task. So here, I've just declared a task that extends Async Task, and then I just execute it and run it in the background, and then once it's done actually being able to load that information, it just goes ahead and puts it right back in the image. So if I had those elements, the user can still interact with my app. I'm still prioritizing how I'm actually loading information, but I'm not interfering with what they're doing. So this would also be good for something like user logins, right? Because that's not something that needs to be used in other activities. So if you have an object that is directly related to what is going on in that activity, Async Task is a very good tool to use. All right, so now we're getting into a little more advanced. You can see how things are starting to get longer and more interesting in terms of what's actually going on. So here we have handler thread. This is a relatively newer thing that they put out, and there's not a lot of great documentation on it. So hopefully this provides some guidance as to how to actually use this. So if we just want to be able to make something run in the background, we can do what I call the basic version at the top. So we just declare a new handler thread, give it a name. We tell it to start, but then we have to give it a looper task. And what does looper actually do? If we talk about like location looper and other things, what we're having is we're generating a thread that we're giving tasks, but we also are saying, hey, I want this thread to stay alive. This is, maybe I'm actually executing multiple image cachings, or I'm executing multiple of a lot of other stuff. I don't want that thread to die. Because every time I generate a new thread, that's more work that has to go on. But you also have to be really careful with this. Why do I need to be very careful with this? Because I can end up having a thread that never dies, right? We talk about that being a good thing, and it can also be a bad thing. Because now, if you're not using that thread, you have computation that is continually going on in the background, and you are using system resources. It's not like it just stays there. So why would I want to have something like this actually run? Well, what if I have a task that I have no idea whether or not it's going to take 5 seconds or 50 seconds? And async task might not be a good idea for it because, I might need it as a system resource. So maybe a good example of this would be camera. So if I am, say, Pokemon Go, right? If I actually looked to dynamically grab your camera for that AR mode every single time, and I didn't lock on it while you actually were using the application, that would add, about 2 seconds of loading time in a lot of cases to be able to load and lock onto that resource. And this is especially true if you're using much older devices too. So maybe I want to have something that actually grabs that resource, figures out whether or not I actually have it before I even get to the point where I show somebody a Pokemon on the screen for them to tap and then have them immediately be able to go into the mode that I know that they're going to want to go to. So what would this be good for? More than just cameras. So let's say you have continuous messaging. So you have let's say you have a chat, right? So you have a chat that's going back and forth, Facebook Messenger, or we'll say Google Hangouts. I'd want to have a looper thread of the instance that I'm currently in to be able to make sure that I'm grabbing those messaging tasks and being able to post those to the front of the application, but also still be able to get those bits of information even if I go to another application. So you know how you get those notifications that, hey, somebody just sent you another message? You can still keep that instance going and still keep that prioritization without actually affecting what's immediately in front of them. So if you did that in async task, that wouldn't be very good, because if they went to another app, the whole thing would kind of lose context. So let's talk a little bit about some new stuff that happened in Java 8. Now I just want to touch on this and how it actually affects threading. So now we have what are called Lambda expressions. So that early example where I was talking about that seeded random takes all this code to write it. And that's not even talking about initialization. Initialization actually remains the same between Java 7 and Java 8. But now I can take all of that information and actually just make it a Lambda expression, which you see on the far right. So that has substantially decreased the amount of code, and in some cases you might call it boilerplate, that I actually have to write. Ooh, now we're into the scary subjects. More advanced threads, thread management and execution and all those things. So let's give a really basic example of what is called a self-managed thread. Now, traditionally when you're in Android, you're going to not declare things as regular thread, you're going to declare them as runnable. It's just another variation of the regular thread class, but it's a more Android-specific version. So what I'm actually doing in here is once I'm actually spawning, I'm keeping myself alive not with a looper, but while I'm in the while statement. So this is a manual example of what is not a particularly Android-y way to do it. So in this example, I'm actually creating a socket level connection with a server and getting very simple responses back. So if I wanted to check, okay, this is a new connection, therefore I know that I need to send and start the client, and then I need to create even another thread from within the thread that I'm already doing. So I'm actually spawning a second thread and then actually causing a timeout. I don't have that thread on here, but you can tell by the name, timeout thread. I have to make sure that if I hit a timeout condition, that I can close it and then close it again. So here, I'm still keeping alive even though I've spawned another thread, and I'm actually waiting to find out if I got a server reply that was a yes, a no, or stop, something's wrong. And if I receive any of those responses, then I actually will interrupt the thread, causing a stop in the while loop, and say, okay, this event completed, and then I'll just return back. So what I've done is created a situation where I can actually start threads from within myself, and then once I know that that task is done, that whole thread closes down. And I've been able to create self-managed tasks so that I know what is going on at every moment. Why could this be a thing? So this is actually a very simplified example of something that I had to write a while ago. I was dealing with a situation where I could actually get hung sockets. I opened this port, I opened this socket, and I can't get anything to communicate. And you'll have some situations where you're using external libraries and they may not handle things so well. So if I didn't know that that was what was happening, I would have all of these new ports generated. Like all of a sudden I was like, oh my gosh, I have 50 ports and the server is not communicating. What is going on? So to keep the things really light and not cause a bunch of new threads to constantly be propagated and be hung like that, I made sure that, hey, I'm going to create a timeout. And then also, once I know what's happened, I'll close the thread, close the socket, make the whole thing happy again so that I'm never causing a situation where I have more than one or two instances going simultaneously. Executors. Okay, so we brought up the kind of self-managed spawning thread example because, well, executors kind of help us with that in a huge way. So if I don't want to do that manually, or at least to that degree, I can use a thing called executors. And not Executor from Pokemon. And it's super effective. It's a sunny day, and it is actually outside. It said it was going to rain. So when I look at how much I actually have to write in order to be able to execute multiple threads and be able to keep them synchronous and all this other stuff, I can do it so much easier using something called an executor. It basically executes runnable tasks. Now, when we talk about runnable tasks, we're literally talking about runnables. We're not talking about the class thread that we talked about at the very beginning of this presentation. So I can do two things with it. So I can make asynchronous threads, and I can spawn them, or I can actually have a situation where I'm making them fully synchronous. So if you look at the top, I have to write this new thread, runnable task, hand it start, and that's assuming I have no other variables to pass into it. Now, with Executor, I can declare a single executor and be able to run multiple tasks on that one executor. That one executor will be able to generate multiple threads for me. So, okay, I just want to be able to execute a single thread in one of my activities, or I have a custom view class or a service, and I just really want a direct call. So what's probably the most common implementation you'll see here is what I called the direct executor. So here we're just giving it the simple runnable task and then just telling it to run. So this way they actually run in the same thread. This is more of a synchronous operation where we're executing one, then executing the next, then executing a third. Now, if I want to be able to generate new threads every single time, then I would use the thread per task executor. And you can see, actually, within the execute function, I'm actually generating a new thread for each time that I'm getting a new task put into it. Ooh, now we have the fancy example of executors, and the one that really you should be using for the most part. Unless you have like one or two simple operations, or you just have a kind of just a very self-contained piece, you probably should be using what's called a thread pool executor. Now, why is this a fancy kind of executor? Well, in thread pool executor, I generate those things, they do their stuff, and then they die. And like I said earlier, it takes a lot of work to actually generate those new threads and new tasks every single time. And if I constantly have new stuff coming up, other stuff dying, that becomes a lot of work for me to be able to track. So what I can do is I can use what's called a thread pool executor. We instantiate it very similarly to how we actually instantiate Executor normally. But in the beginning, we need to make sure that we actually create that thread pool. Now, I'm putting in some random kind of numbers here as examples, but you may not want to have every processor core be able to be used as part of your thread pool, and you want to be able to reuse that thread pool for as long as you actually need those pieces to go. So you could have a situation where you have an application that has multiple thread pool executors, or it has a single thread pool executor. So you could do it based off of like per task, right? So if I have a thread pool that I need to have dedicated to preloading images, that would be a good reason to have its own thread pool. But if you're talking about something where I want to be able to constantly access it, I've got an API that I'm constantly hitting, or multiple APIs, hey, I might want to keep one thread pool executor just for that purpose, and it might be my general purpose thread pool executor because I always have stuff that's running. I never really truly need to close it down unless I'm no longer using the application. Now, again, we talked about, hey, this is something that's really simple to use, and we use it just like we would execute. Now, probably the most common thing that I see happen is they're like, oh, thread pool executor is great. I need to thread pool execute every single thing. No, you don't. You need to make sure that you're using it only in instances where you are going to constantly be needing the workers that are in that container. And then once you are done, you need to shut it down. And this is why I do make sure to put thread pool shutdown. When you are done with those tasks, do not keep those worker threads going. Do not keep them alive. Kill them. Kill them with fire. They are ants. They are very good at moving things from one place to the next. But as soon as they show up in your house, shh, take care of them. So this is something I'm just going to touch on because it's really related to futures, which I talked about at the beginning as being kind of a derivative of one of the kind of 4 cores. But here you can see it's a very similar thing to when we're talking about the standard executor, except that I'm doing this on a fixed thread pool, so I don't have the ability to kind of change some of those parameters. And this is really geared very much towards specific things. So if you're kind of familiar with like Java promises, that's kind of the best analog. Sorry, not Java promises, JavaScript promises in some libraries. It's probably the closest thing to what a future is. So it's really here more for example. Now we get into RxJava and libraries that have their own thread management. Now, I'm not trying to start a flame war. I'm not for one side or the other. I'm for myself, whatever works. But we're going to touch on RxJava first. So some of you guys are in this class and going, hey, I don't need to know anything about thread management, thread pools, executors, any of that stuff. There's a library that does that. Except for, guys, you need to know how this works, because ultimately if you get in the practice of using libraries that you don't understand what's actually going on under the hood, you are going to make mistakes. And I see this very, very commonly, where you have situations where you have leaked messages and observables and things that are still active because people didn't know that they should close it down. It's not going to be perfect, right? Because it's taking a general execution model to what might be a very specific problem that you have. And again, it's event and task-based, so self-propagating processes where I'm actually like doing extra spawning, I might want to have some things run concurrently and some things run synchronously. It's going to be a lot harder for you to set it up in RxJava. But what does RxJava actually give us? Now, if you're looking at being able to very simply pass bits of information from one activity or class to another, RxJava can make it quite easy to gather that and then be able to return back just those objects. So it can significantly simplify the writing of modules. So if we're talking about login as a thing, right? So I can write a very short bit of RxJava code to be able to handle login, and I don't have to write 3 or 4 little threads to be able to handle all of the eccentricities of OAuth and all these other problems that you've had if you've tried to actually build your own login service. And what else does it give us? Very easy to set up communication between multiple threads. So when I was showing you the examples earlier, if I wanted to do that, I had to make a custom way for those variables to be passed back and forth and handled between the two. In this case, they have already tools to be able to do that. So if you have information that needs to be passed back and forth between multiple threads, you don't have to build it manually. They already give you stuff to do that. And if you need to serialize results, again, when I was talking about being able to run some things asynchronously, some things very synchronously, you can do that in RxJava without too much work, and you don't have to think about how the processes are actually operating in your head. So the biggest challenge that a lot of people have is being able to understand when do I need to have concurrent information and when do I need to have things that are basically in a line. So other examples of things that have self-managing libraries. So retrofit. A lot of us actually use this. I use it a lot. It really, really simplifies calls to your RESTful APIs. And it's actually a specialty built thing. So it does use like RxJava in the back end, but remember that it's using RxJava in a very specific capacity, and it's been optimized for that. So it's very good at handling your RESTful call, give you back the information, turn it into an interface so that you don't really have to know that much about being able to do custom API calls. And as an alternative to RxJava, because that is another talk later today, Bolt's Android. So this is something that's been open sourced by Parse and Facebook. They use it within their application. And it's a good event-based model to be able to work back and forth. It doesn't have as many advanced features, but if you're looking to do things that are very simple from a call and execute system, Bolt Android is a very good library because it's very purpose-built. Again, Picasso and Glide. Now they actually handle things a little bit differently in terms of what they do in terms of threading under the hood, even though they have very similar results in terms of thread performance. So they're both specialty packages built to be image loaders. Glide actually uses thread pool executor and a lot of specialty handlers on the underside. And depending on what version of Picasso you have, it's primarily using thread pool executor. And some newer stuff I've seen actually uses RxJava in the back end. So thank you guys. Thanks to all the people on this, as well as everybody like actually paying attention. I know it's a very complicated subject, but feel free to come up and ask me questions, especially because there are so many more ways to do advanced threading and jobs and tasks and everything else within Android that is very Android specific. And as much as the developer.google site really does have great examples, there's not a lot of great examples on some of those more advanced pieces, and there's not a lot of stuff on Stack Overflow. So again, feel free to contact me with the slide that I posted up. And we have some questions that I'm going to ask you so that you can have one of these awesome plushies. So I brought this example up a lot. What would be a way that I maybe want to handle login in terms of thread management? What kind of threads would I want to put up, and how would that actually work? Hands? Okay, hands. And why would I use Async Task, and in what capacity would that give me the information that I need? Right, so if I have something where I need to log in for them to be able to do something, that's a really, really good place to do it, right? So do you want the Flash Android, or do you want Kill Bill Android? Kill Bill. All right, feel free and come on up. What's another good thing for me to bring up? All right, since I brought up the examples of image loading a couple of times, because it's a very common problem that we have with caching, loading, being able to grab other information ahead of time. If I wanted to make my own custom image loader, what kind of threads or thread management would I want to be able to put together if I wasn't using something like Picasso or Glide to do it? That'd be you. Yes. And be very, very enunciated. Thread pool executor. How would I use thread pool executor in combination with other threads to accomplish that task? Right, so I'd make like a runnable or a new thread to handle different tasks, right? So I'd have the situation where I'd say, okay, I want to have this thread pool, but here I want to actually download the image. Once I'm done downloading the image, maybe I do a resize, maybe I do something else after that, and have that all run within that single execution. But when I'm done with it, what might I want to do with that thread pool? Stop it, shut it down. Now, an important thing I didn't bring up in here is that thread pools don't immediately shut down. You send a shutdown signal. It's kind of like the difference between when you hold the power button on your laptop versus when you say power down to your laptop, right? So when I say shut down, I'm telling it, hey, once you're finished, I need you to shut down. But what if I have a thread that's just gone crazy? A thread that I've passed something to and it just doesn't want to die, a zombie thread. What I can do in that situation is I can see, hey, after a certain amount of time, did these threads execute what they needed to and then shut down? If they didn't, I can tell it to shut down now, right? It's the difference between when you hit the power button on your computer to say, I need this off. I just got a million things of spyware. It won't go down. So, sir, you get the Flash. And I have a bunch of stickers, and then I also have like earrings for the ladies or men. They're women tech maker earrings that I made, so thank you. They're hypoallergenic. So who has questions for me? I know that this was a lot of information. I tried to touch just a little bit and keep the examples really short so that they were fairly easy to understand, or at least, dear God, I hope so. Sir. So the same way that you saw that I did things in that kind of simplified double spawning thread, right? I want to be able to either set a variable or be able to pass it back to some external class. So you would treat it just like you would passing information back from a standard method or function that you have. So instead of thinking about it as kind of so async task, I've seen some weird stuff where somebody made a blank activity and a bunch of custom constructors around their async task system. Don't do that. Keep it really to the very simplified tasks that you just need in that one instance. So in your case, you really just want to treat it like you would any other information or any other function, because really all you're doing is just running other functions inside of another thread. the variables, you can quite easily pass those back. Basically because so the reason being is that it was either some sort of derivative of other things. So what I talked about earlier is there is a ton of different stuff. So like intent service. I didn't bring up intent service because actually at its core, it's a derivative of handler thread. So if you understand how kind of those core pieces work, it's very easy to be able to look at those other things like loaders and be able to see what it's doing and what it's returning back to you. So yes, that is a very valid thing. Right, so what you would do is basically once you hit your shutdown, you have another piece of code like a try-catch statement to figure out, okay, I need to wait, have I counted this many times, right? And if I don't shut down in a certain amount of time, I need to send what's called shutdown now. That is the power button on your threads. So there is a dedicated method for that. I just can't remember it off the top of my head, but it is very well documented in the developer.android async examples. I mean, it's very common. I tried not to touch on it too much because it's probably the first thing you've ever seen when it comes to threading. And I really just wanted to cover stuff that, hey, it doesn't always get brought up all the time. Anybody else have any questions? Cool, way to win, everybody. We did it. We know how to manage threads.